Hello! Modern aviation is already an established industry, with its own restrictions, balance, and laws. And that's how it should be in theory, but there is a side effect. It's boring. While aviators, like Warhammer fans, endlessly argue about how much composites to use in airplanes, the average person has to watch videos telling how a Boeing 767 can be distinguished from an Airbus A330 by the shape of the windshield windows. And everyone remembers the times of their wild youth, when engineers behaved like mad scientists. Their devices were Frankenstein's monsters, and these monsters were driven by test pilots whose extreme skills even Michael Bay would envy. Hello aviators, Sky here, and we are in Patriot Park, looking at the intersection of these two worlds. A machine that is already correct and logical, but still with a touch of adventure. I present to you the Mi-26. The 1950s and 60s. The era of raging development of aviation in all directions, including, of course, helicopters. The Mille Design Bureau, which created the 7.5-ton Mi-4 in 1952, already in 1957 lifted the Mi-6 into the air, the carrying capacity of which was greater than the maximum weight of the Mi-4. The military, seeing the trends, wanted an even more powerful machine, with a lifting capacity of almost 20 tons. And the engineers, in their courage, suggested as much as 40 tons. The idea was to create, in fact, a rotary wing on 22. Thus, the V-12, also known as the Mi-12, was born, a flying building the size of an airliner. And this building was designed, assembled, flight tested, broke a bunch of world records, and sent to a museum. The size of this colossus was comparable only to the number of potential problems during its operation. In fact, having seen it, the military asked themselves, do we even need this? The V-12 was a vivid illustration of the word overkill. This was the very moment in history when crazy ambitions gave way to adequate ambitions. Having abandoned the V-12, customers asked the engineers to be a little more modest and return to the target cargo weight of 20 tons. At first they really were modest. The Mi-6M project assumed modernization with an increase in cargo capacity. Well, not really a modernization. It was clear from the very beginning that almost everything would have to be redone. Once again, they had to choose between layouts, among which was a classic single rotor like the Mi-6, a tandem with two rotors in the front and back like the Chinook, and the transverse one with two rotors on the sides like the V-12. After long debates between several teams, in 1971 the classic was chosen. The Mille team already had a lot of experience working with such a layout. It would be easier to design and then master. And it immediately became clear that this was not the Mi-6M. The project with the factory index Izdelia 90 received a new name, Mi-26. And creating the Mi-26 was impossible. Or rather, it was possible, of course, but the customers didn't want another contender for the Guinness World Records, but a normal machine that would, work. And there were problems with this. The helicopter turned out to be too heavy, complicated, and unreliable. The technology simply did not reach the level. Large-scale research began, which had to develop everything: mathematical models, design methods, materials, and production. Components were created and tested in advance, even before the helicopters themselves were created. It was a transitional period in engineering, when solutions are maximally worked out in advance, and the new machine takes off practically ready. Long, boring, but effective. Although even now there are guys who prefer to learn in practice, so to speak. In 1972, the Mi-26 was submitted to a competition for a new heavy military transport helicopter, where it was opposed by the Ka-35 project. The Ka-35, the successor of the Ka-22, was an impressive but rather exotic machine, and the military, I repeat, was tired of exotics, so the winner was the classic Mi-26. In 1975, the Moscow helicopter plant began assembling the first machines. The flying prototype was ready in 1977, and in December it took off for the first time. The testing program was very extensive. Everything had to be tested, from the methods of securing the stretchers to emergency landings on auto-rotation, with engines turned off. On this. but the machine showed itself quite well. In 1980, the Mi-26 completed the main testing phase and was accepted into service. Curiously, the helicopter, now considered the largest and heaviest in the world, was classified as a medium class at the time. Despite the fact that the V-12 was no longer expected, the heavy class was still formally reserved for monsters like it. Later, when the issue of 100-ton helicopters was closed, the classification was adjusted, and the Mi-26 took its well-deserved niche as a heavy. Now let's move back to our hero. The helicopter on display here is one of the early representatives of its type, a basic military Mi-26 born in 1985. It served its homeland for 30 years and in 2015 left the Russian airspace forces, after which it ended up here, surrounded by the attention of museum staff and volunteers. Well, let's take a look. The general design of the Mi-26 is more or less classic, except that everything here is huge. The fuselage is 33.7 meters long. The overall length with propellers is 40 meters, which is, mind you, the size of a Boeing 737-800. The height is that of a 3-story building, 8.1 meters along the main rotor. The tip of the tail rotor reaches 11 meters. In the struggle for flight performance, the designers made the helicopter as light as possible, no matter how strange it may sound, and aerodynamic. It is clean and streamlined, practically without external structures. Compared to most of its colleagues, it seems like some kind of a naked whale. The maximum takeoff weight of this whale is 56 tons. For understanding, it's the approximate weight of the E-190-E2 airliner. The helicopter has practically no aerodynamic surfaces, except for the fin and large dynamic stabilizer on the tail. The tail turned out to be quite peculiar. It was made as a kind of semi-oval cut off from below, to give more space to the cargo hatch. And this semi-oval turned out to be subject to vibrations in flight and possibly fragile. In case of a hard landing, there was a chance that the landing gear would hold, but the tail would break. So the beam was reinforced, which is why these stringer strips appeared below. Also, considering that the helicopter was supposed to operate in regions with underdeveloped infrastructure, the MIL team made sure that it was not demanding on local tools. The ladders are integrated into the design. The personnel can work with the Powerplant directly on the folding cowls, and the tail rotor mechanisms can be reached either on foot along the tail boom or crawling through the tail boom. The size gives its bonuses.
Mi-26 большой вертолет, говорили они. Легко обслуживать, говорили они.
The landing gear is appropriate. The front rotating leg is two-wheeled. The main gear has two legs with wheels with a diameter of 112 centimeters. The landing gear is non-retractable, and by and large it is the only thing that sticks out from the maximally clean fuselage. Now let's see how the helicopter does its main job, works with cargo. The cargo bay is 12 meters long, 3.2 meters wide and 3.1 meters high. The helicopter can carry up to 85 soldiers, 70 paratroopers or 60 stretchers with medics. The payload weight is the coveted 20 tons, which includes most of the military cargo, at least at that time. You can't fit a tank in there, but you can fit an IFV. In fact, it can carry even more. Once it lifted as much as 25 tons to 4 kilometers. But that was a record flight. This is not practiced in normal operation. Access on board is provided via 3 doors on the sides of the fuselage, as well as the main cargo door located at the rear under the tail boom. It consists of 2 large doors and a lowering ramp. Cargo can be handled by a pair of winches, as well as hoists under the ceiling. In order not to interfere with movements under the boom, the protective support of the tail rotor can be removed, and to simplify loading, the main gear can adjust the legs, raising and lowering the entire fuselage. Something similar can be seen on the C-5 and An-124. In general, when describing the possibilities of working with cargo, I can't shake the feeling that I'm not describing a transport helicopter, but a military transport plane, and in some places quite the specific one. I assume that the military had an idea to get a rotary wing brother of the Un-12, especially since the V-12 project not so long ago was openly positioned as a brother of the Un-22. Of course, there is also an external suspension. In the floor of the cargo bay, there is a special niche with fasteners that allow you to hold any oversized cargo on a cable. The nose of the helicopter also resembles the nose of an airplane, clean and streamlined, relatively. The glazing is made in principle in the style of all Mil helicopters, but taking into account the scale. There are also bulged windows, allowing observation a little on the outside. The cockpit is pressurized and large. The helicopter crew is quite diverse, but in the base it is at least 5 people. The captain, the second pilot, the navigator, the flight engineer, and the flight technician. Ideally, you need to take 2 flight technicians. Plus, there are 4 more seats for additional passengers. The helicopter control is quite advanced, with 3 integrated hydraulic systems like an airplane, and decent automation. Thanks to this, the huge machine turned out to be quite compliant to the crew, and not difficult to pilot. Most of the onboard systems are located here. In the nose cone under the fairing is the radar. Under the floor, communications, navigation, air conditioning, control, and suddenly the auxiliary power unit. How did it end up here? I don't know. Probably they didn't want to put it in the cargo bay, or even more so outside under the fairings. And it's definitely easier to service it here than if it were somewhere up there. Now the most interesting part of the design, the creation of which was a whole story in itself. The helicopter needed a power plant capable of holding 56 tons, reliable and efficient. The Mil engineers wanted their giant to have 2 hearts, like a space marine. Well, or like the rest of their helicopters, which were equipped with 2 engines duplicating each other. The problem was that in this case, each engine had to produce more than 10,000 horsepower, and there weren't any like that in the world. Luckily, the D-36 was being born at the same time, a very interesting engine that can be seen on the Yak-42, An-72 and An-74. A turbofan on a helicopter is of course out of place, but they decided to make a suitable turboshaft on its basis. Thus, the D-136 was born, the most epic helicopter engine in the world, whose power fluctuates between 6,100 horsepower in cruise mode to 11,400 horsepower in maximum takeoff mode. The engines are located in a pair above the cargo bay, in front of the rotor hub. They are covered by dust protection devices in front. There is another air intake on top, but it is without an engine. This is the Powerplant cooling system unit. 22,800 horsepower is sent to the transmission. When creating it, the engineers had to take a risk and adopt a new multi-flow mechanism, but the result was worth it. The VR26 gearbox turned out to be very successful, efficient, reliable, and not so big and heavy, given the context of course. And above this whole kingdom of fire and metal, it rises. The Mi-26 rotor itself is a miracle of engineering thought, which included at one time the best solutions in both aerodynamics and materials. A significant part of the design is composite. Yes, even then, in the 1970s. 8 blades are attached to a huge titanium hub. What is curious is that this 32-meter crown is smaller in diameter than that of the Mi-6, but thanks to new solutions it is much more efficient and, at the same time, also lighter. The 5-bladed tail rotor with a diameter of 7.6 meters is 40 centimeters smaller than the main rotor of the OH-6 Cayuse helicopter, and it is also almost entirely composite. There is no comparison with the tail rotor of the Mi-6. The old guy's was basically wooden. The power plant is fed by a fuel system. Under the floor of the cargo bay is a group of tanks with a total capacity of 12,000 liters. This reserve is enough for a flight to a distance of up to 800 kilometers, with a maximum load up to 475 kilometers. There is also a trick. When ferrying without cargo, additional tanks can be placed in the cargo bay, which allow it to increase the range to 1,500 to 2,000 kilometers. All this technological dance provides the helicopter with quite good flight performance. 265 km/h cruise, 295 maximum. Even the Mi-8 was slower. The practical ceiling is about 4,600 meters. If you try, you can jump to 6,500 with acceleration. But this is all taking into account various relatively small loads. During record flights in 1982, the Mi-26 with a maximum takeoff weight of about 56.8 tons rose 2 kilometers. All these descriptions are of course fascinating, but you can understand how much of a step forward the Mi-26 was only by comparing it to its ancestor. And yes, the Mi-6 seems like a dinosaur next to it. On the one hand, the Mi-6 and Mi-26 are very close. The 26 is only slightly larger than the 6, and its empty weight is only 1.7 tons greater. But thanks to advanced solutions, the Mi-26 began to fly much more confidently. And most importantly, the increase in the efficiency of working with cargo is striking. The cargo hold has become noticeably more spacious, and the carrying capacity has almost doubled. The new generation has arrived. The public demonstration of the Mi-26 was held in 1981 at the Paris Air Show. Around the same time, it received its NATO index, Halo, and journalists praising the machine looked at representatives of Sikorsky and Boeing with disappointment. Here I can make a comment that often accompanies the description of the Mi-26, that no one else has been able to make such a powerful helicopter, sometimes with a grin that the competitors are simply weak. You have to keep in mind the context. The USSR was a gigantic country that physically could not build a full-fledged infrastructure on its entire territory, and it was helicopters which were not demanding on airfields that had to solve this problem. This is the root of the Soviet passion for large cargo helicopters. In most other countries, the importance of such aircraft is not so critical. Plus, in the United States, when creating helicopters, their potential use in the Navy is taken into account, and basing a giant on an aircraft carrier would be, to put it mildly, inconvenient. Boeing had its own XCH-62 HLH project, a kind of giant Chinook, but after several years of work, it became clear that such a complex and expensive machine simply would not justify itself, and they abandoned it, limiting themselves to a modernization project, Sikorsky CH-53E Super Stallion, with a lifting capacity of 15 to 16 tons. The same is now being done by the Chinese AVIC. The AHL project is being created jointly with Russia, and in a number of technical solutions resembles the Mi-26, but with a lifting capacity of the same 15 tons. It is simpler, cheaper, and yes, it can also work on aircraft carriers. Serial production of the Mi-26 was launched at the Rostov helicopter plant, and the first serial machines began to be delivered immediately after the completion of tests in 1980. And the process of mastering the new machine was difficult. The helicopter suffered from a large number of initial problems. Nothing surprising or critical, but quite a lot of time was spent on improvements and updates. Nevertheless, the Mi-26 with solved problems was very pleasing to the military. Its performance is amazing, piloting is comfortable, and maintenance is not as complicated as many had expected. The helicopter handled loads that could previously only be carried on airplanes, and what it managed to carry on its external sling is beyond listing, from firefighting equipment to building structures, and most impressively its own brothers. The Mi-26's baptism of fire took place in 1984 in Afghanistan. Flying in a war zone on a huge and heavy helicopter, especially in hot and high conditions, is not much fun, and the flying cow, as the military nicknamed it, risked becoming an easy target for a bearded man with a stinger. So the 26 tried not to work in the depths of the country, performing mainly cross-border transportation between the USSR and northern Afghanistan. Caution paid off. The statistics of combat losses at that time remained empty. The helicopter found unexpected and no less dangerous work in 1986 in Chernobyl, where the Mi-26 flew with its brothers to combat the consequences of the nuclear disaster. They did their job, but most of the machines, having received critical radiation doses, could no longer serve. Simply being on board was harmful to health. With the collapse of the USSR, several military conflicts broke out in its territory, and the Mi-26s operating in the Caucasus fell victim to them several times. The most terrifying story happened in 2002, when the Flying Cow finally met its bearded men with the SA-18 SAM. The missile caused serious damage to the helicopter, which was also terribly overloaded, so the emergency landing was very hard, and on a minefield. The result of this evil fate was a nightmare, in which only 20 people survived, out of 147 on board. But this story didn't affect the reputation of the Mi-26 that much. Let's be honest, it's hard to blame it for the crash. The machines continue to serve and are still flying actively, quite successfully and without any particular drama. The Mi-26 continued to receive many modifications that expanded its functionality in various directions. Externally, they are not much different from each other, a bonus of size. Most changes can be achieved by modifying the equipment and installing tools inside. The helicopter reached civilian use in 1985, when the Mi-26T modification began to be produced. It was different from the military original mainly by replacing military components with civilian ones. The Mi-26Ts actively transported various types of cargo inside cabins and on external slings, acting as flying trucks and cranes, especially in Siberia, a region with impressive resources and sizes and unimpressive infrastructure. And the appearance of the Mi-26 led to completely tectonic changes in logistics, transportation methods, and even the adaptation of cargo for transport. Not to mention the fact that the giant simply left a bunch of its relatives without work. First of all, the Mi-6. The helicopter has also found its place in foreign transportation markets. The Mi-26 is often rented to perform complex tasks, from transportation and construction to peacekeeping missions. Demand is limited since the machine is, after all, complex and expensive, but stable, since only it can perform a number of operations. It is somewhat similar to the transportation market niche of such aircraft as, for example, the An-124. Purchases are also happening. The first deliveries were made back in the 1980s to India. Now, the Mi-26 can be seen in the fleets of a dozen countries around the world. The largest operators at the moment are obviously the Russian Airspace Forces and not obviously the Algerian Air Force. Production volumes grew rapidly in the first years, reaching a record in 1990, 38 units per year. But the collapse of the USSR overturned all this success. Deliveries fell to single units, and all development plans were cut short. The situation began to improve only in 2010, when they decided to modernize the Mi-26 by mass introduction of modern technologies, mainly in the onboard equipment. Everything from the radar and engine automation to the cockpit, which is practically new here. Glass with a modified layout and without a navigator. This allowed expanding the capabilities of the helicopter and improving its economy. Thus, in 2011, the civilian Mi-26 T2, which is considered the current version, took to the skies for the first time. Then it was time to update the military transport. The Mi-26 T2 was redesigned again, based on the experience of use in military operations, and received new military equipment. Thus, in 2018, the Mi-26 T2V took off for the first time, and has now become serial. In the future, we can probably expect something else. For example, new engines, replacing the D-136 with presumably the PD-8V, a turboshaft relative of the new Superjet engine. But this prospect is not for the very near future. One of the achievements of the Mille Design Bureau was the solution to the main problem. The Mi-26 managed to become not a unique machine in single copies, but a full-fledged working transport. In the technology race, many epic devices cannot overcome this barrier, ultimately conquering not the sky, but museum sites. The Mi-26 is still being produced, and at the moment, the total volume of deliveries exceeds the mark of 300 units, which is quite good for such a thing. More than half a century has passed since the first flight, and the Mi-26 still has no direct competitors, and given the modern trends, it will probably remain the king in the hill for a very long time. Well, let's wish it to continue to shine on this peak in the future. Thanks to the Patriot Puck for letting us run at the feet of a real Titan. And thanks to the volunteers for taking care of this Titan. Fast flights on epic machines and soft landings to you.
Okay.